So in the introduction of signal and system, the two part of this introduction, one is the signals, another is the system. Our syllabus is divided into five module mainly. So first module is based on the signal and system. Second module is based on the signal properties, sampling and signal operations. And third module is based on the Fouriers. Fourth module is based on the Z transformation. Fifth module is a signal noise cancellation and stochastic analysis. So mainly, main few parts of this signal system is signal analysis and understanding signal, analysis of the signal, signal transformation, and noise cancellation. So based on this main part, now I'm going to start the introduction of the signals and system. What is the signals? First, I'm going to emphasize the signals. So what is the signal? First point of this signal I can highlight, signal is a physical quantity that contains the information. So if you see any first signals as whole, we will see that in the road, that is a traffic signals. You can see that some of the signal traffic signal having three type of light. One is a green, another red, another yellow. So they don't need to give you any instruction by verbally or by any written instruction to any of the means any of the driver to that to stop or to move. But we understand these things by seeing the light, because we know the meaning of the light, because red light shows that the immediate stop of the vehicle. So this is the way the signal is working. The signal is a way to give us information, not only give us information to one end to the another end. So I can say that the physical quantity that contains contains information. The physical quantity that contains information. And in another way, in mathematically, I can say that the signal is that is a physical means that is a means definition of normal person, those who can know the signal processing as mathematical. But in case of in view of the in signal processing engineer and mathematicians viewpoint, the signals definition is the signals are expressed mathematically as a function of independent variable. So now the term coming the independent variable. So variable, I'm coming to the variable. So variables are two types. One is the dependent variable. One is the independent variable. So what is a dependent variable? If I'm giving one example of a dependent variable, so two axes of normally two-dimensional cases, two-dimensional two-dimensional graph, we can see that two variables are there. One is the x-axis uh, and another is the y-axis. That is a simple most graph, two-dimensional. So in this graph, if you observe in x-axis and y-axis, so x-axis is varying based on the y-axis is varying based on the x-axis. So generally, we represent the variables that in x-axis, that is the independent variable, and in y-axis we are representing the dependent variable. If I want to plot one graph of ft, graph of ft may varies with t may be represented in x-axis. So we can say that ft varies with respect to t, with respect to t. So ft varies with respect to t. T is an independent variable. So ft, value of ft is a dependent variable. So ft is a dependent variable and t is the independent variable. Independent variable, already I am giving you that t. T is a, t may be time, t may be anything. So t, what type of independent variable may be possible? Example, time. Time, why I am calling time is always independent. Time not having any boundings. Time can't hear our voice. We can follow the time. Time is always independent variable. If any of the cases mathematics, if you find that time is present in the graph, so always time is expressed in the x-axis, because time is the independent variable. Maybe some of the cases you can see that the length is the independent variable. Some of the cases you can see that temperature is independent variable. So not only temperature, say I want to note down a temperature of room, and based on the time. So here also time is coming as an independent variable. So time is a very means supporting variable that you can express as an independent variable. So everything is moving with respect to the time that you have came to attend the class on 10:30. That is, you are following the time. I am also following the time. Everyone following the time. So we are bound to follow the time. Time is an independent variable, and if we express any of the variable in with respect to the time, the variable is a dependent variable. So two type of variables are there: independent variable and dependent variable. So if I want to express a graph of fx, if I want to express a graph of fx, so x should be expressed in the x-axis, and fx is expressed in the y-axis. So this graph may be like this. This graph may be like this. So x, positive x and negative x. This one you can I can means express this x equals to 0 in here. This one is the origin. When fx is 0, x is 0. So this fx may vary like this. Fx may vary differently also. So it is up to the equation, up to the condition, that how this fx is varying with respect to the x. So here x is the independent variable, fx is a dependent variable. So this one is one another example I can give you like this. Say this one is time, t. X-axis we can express the time, and y-axis we can express the f of t. So f of t may be vary like this. In last graph I can I'm showing you effective is varying like this. So this is the conditions, this is the situation or scenario or cases that f of t may be constant for some of the time, and before this starting of this time may be here, may be 0, t equals to 0. So 0 means this one is a positive side, 1 2 3 4 5. Here -1 -2 -3 -4. So here it is f of t in the negative negative axis of the time, that f of t is constant. Some of the cases after that f of t is 0. So this is a way that signals normally represented in that graphical mode. The graphs of signals whenever we have plotted signal, that signal is a graph. When we express the mathematics, so if we express the mathematically, if we want to express this in mathematical way, so how can we express this in mathematical way? Say here it is 1 2 3, here it is 4, maybe 4, and here -1 -2 -3. So f of t is varying from -3 to +4. So I can say that f of t is equals to 1. Say I can give you the amplitude of this, height of this f of t is 1. So 1 is constant and here is 0. So is 0 1, say 2 3, I can distribute this y-axis also. Like this x-axis I can distribute y-axis also. So f of t is 1 for t, greater than equals to 4 and less than equals to, no, greater than equals to -3 less than equals to 4. So minus 3 to 4 I can express once again. I need to erase it. So t greater than equals to minus 3, t greater than equals to minus 3, less than equals to 4. So and other values is 0 otherwise. So this is the mathematic way of mathematically representation of the signal. Same signal can be represented like this graphical mode. So this one is a representation of the signal. We can various representation of the signal. I will discuss later on the signal representations also. This one is the introduction. So I am giving you overview of these things, how we are representing generally signals. This one is a graphical representation of signal. This one is a mathematical representation of signal. And you have to understand both the things, otherwise you can't know this signal and system subject. Next one is that this one is overview of the signals. Now I'm going to give you idea about the systems. Mm. As I have told you that earlier in that the whole universe is a system, and everything is controlled by different particles. That particles are stars, that particles are planet, that are subplanet. So these all are related to each other, all are connected to every particle. Whole the system is whole the universe is a system. So if we say in a control system viewpoint, a system is an interconnection of different physical components. So in control system viewpoint, control system view, in control system view, a system is a interconnection of different physical quantity or physical components which acts together as an entire unit to perform a certain objective. So system is a interconnection of different component, physical component. Like this, as example, I can say you that it is an interconnection of many physical components. Like this is a fan. If you see a fan, fan is containing blades, fan having motor, fan having housing cover, fan having down rod. But the thing is that fan is entirely working as a fulfill of a objective. What is the objective of fan? To give to circulate the air. So fan is an entire body, means is an entire system, an entire unit, but the unit is consisting of the various components. The components are blade, shaft, ball bearing, motors, etc., etc. But but as a whole, it is working together for a certain objective. So the system is like this. And if you so this is every part of this system is not you can't count the every part as in individually. So system is as a whole the thing. And the objective of the system is one, and maybe both two or maybe multiple objectives should be there. but the as a whole, the means as a whole it is working as a means as a unit. System is like this. And now I can give you a block diagram of a system. If I think that this block is a system, so from signal system viewpoint, this is a control system view. This is a control system view, but signal system viewpoint, if I imagine that is a block of this block is a system. So if I give means system is a means here also you can say that the system is an interconnection of different physical component, but which is used to convert one form of signal into other form. Means I can say in signal system viewpoint, view, system is interconnection of different physical components which is used to convert one form of signal into other. Like this, if I'm talking about this block of the system. So if I give one say signal in input as x of t, this one is the input side, this one is the output side. So if I give the input of x of t, I can get some output. That output is one form of signal, say form maybe yt. Yt is a different thing, but don't concentrate on the name of these things. So I can say that this is a signal form, signal of form 1, form 1. So I can get from the output signal of form 2, form 2. So one type of things to the another type of things. It means the property of the system is to convert this in one type to the other type. Like this, if I'm designed one system that amplifier system. So if I'm talking about the amplifier, amplifier may enhance the amplitude, voice. So if I'm talking in front of a microphone, so the voice coming from the speaker, that is the amplified voice. So the system of the amplifier is amplifying the voice. That means it gives some amplitude means amplitude raise to the voice, rise of amplitude. So this is a one kind of system that makes the change in the input, and that reflects the change is reflected from the output side. So if I talking about if I'm talking if x of t is an if x of t, I'm drawing one another block that may be clear to you. So I'm giving you here example of this, example given mobile. So is a real time example mobile. What mobile does basically, what mobile does, mobile we are talking in front of the mobile, or if you can see if you can think about the PNT connection, the landline connection that we have that is now backdated, you can say that. So this in front of this speaker we are saying something information, that sharing information, sharing messages, that message is converted to the electromagnetic wave. This electromagnetic wave is transmitted to the wire, and wire after that the receiver end, that is the electromagnetic wave again converted to the speech. So in this way you can see this two type of conversions are conducting in this in your end, that is a transmitter end. The transmitter converted the speech to the electromagnetic wave, and after that in the transmitter end, if you see that the electromagnetic wave also converted to the speech wave or sound wave that should be audible for the receiver that present in the far away from you. So that is a means view of the system that is a definite means example of the system working, how the system is working. And in mathematical viewpoint, if I'm saying this one is a system, and this system does the square form. So if I'm giving input to the x of t, if I am giving input x of t, so output side, and this one is the input side, this one is the output side. If I observe in the output side, so output side we will see this square form of the input. So if yt is the output, you can see that yt is the square of the x of t. So what the system basically does, system is squaring the input. That output is a y of t. Y of t, if you see the y of t, if you analyze the y of t, you observe that it is the values of every values of x of t is coming as a square